Okay, we'll start straight away. Yeah, hi everyone. My name is Sagar Kakkala, and now here we are for a DevOps session. I think we are in day 13, like Prometheus and Grafana. So in this session, we'll learn how Prometheus is helpful and like why Grafana is used. And before we start into DevOps session, since in Sagar Kakkala's world, it's not just only constrained to DevOps, since it's diversified content of like podcasts and finance and bit of other stuff. I'll just share screen to show how things work here. One second. Okay, yeah. One second. Uh, okay. Yes, fine. Mm. Yeah, you just have to remember my name, Sagar Kakkala. You have to like search in Google, and then like you'll have my like LinkedIn, website, LinkedIn, and YouTube. And then like in website, like everything is separated by contents of the blog. Like any blog you open, you could just navigate back by just clicking on logo and you'll get to like contents of blog. And apart from this, like in YouTube, like everything is separated by, yeah, everything is separated by playlist. So the main playlist will be in the home tab. The recording like which we are going to like put is in like DevOps with Sargakala English. I recommend like everyone like who's watching like post I upload it in YouTube to go it in a day-wise order to understand it better. But here in this session, like the Prometheus and Grafana, like this, I made it as an individual session, so everyone like who's not in inline as well could understand it better. So we'll start straight away. So first thing is like Prometheus and Grafana using official Helm charts. And let's say like before we start, you had to learn about like observability. Let's say like if we go for monitoring, let's say if something happens in or like your pod is not up or something is happening, your Docker image is not up to the mark or like your application is down. There like we'll have observability as a concept, which is like a very common term in DevSecOps. In observability, you would have again the three parts, like namely logs, traces, and metrics. So what do you mean by logs? Logs is nothing but like if something went wrong, let's say even in Kubernetes you could see the logs like for like what's happening. Traces is like in-depth logs you could say, like you could just dive deeper, like where the error went, the application went. Whereas metrics, you could compare it more like your CPU usage or like disk usage. Let's say what happens, like why metrics stands as like the number one, like in observability, like the common observability, like most common target would be metrics. And why metrics comes, let's say like you have an application server. Maybe you might have heard there might be an application crash, like how the application crash happens. So simply like there is an user, let's say like our application is running on a website and website like whenever user access that website, let's say just our website itself like haridev.gold or some, what happened? Tangite joined, okay, fine, yeah. So whenever a user access our website, like what happens is this indirectly gets some load on server. Like server in the sense, in our case, it's EC2 in which our application is running. Like if it is one user, because of that, like whatever EC2 we had taken, based on that capacity, it's okay for us, if it is let's say if it is a small medium capacity server and instead of one user, let's say like something became viral and like everyone wants to check our application and at a time because our traffic, let's say like we designed our website for traffic of 20 users, just for example, 20 users. And like let's say and everyone wants to check out the website due to something happened and like everyone wants to check the application at that time. it will be 1,000 users, but our website is not ready to go for 20 users. At this time, like what happens is the CPU load inside the server gets increased. So one thing to prevent is like when you know, like let's say from 20, if it is moving into 30, the CPU load starts increasing, and like when it's moving into 40, the CPU load starts increasing. Based on that, like we'll increase the capacity, or like that is like increasing the capacity is nothing but vertical scaling in AWS concept, or we will keep another instance and distribute the load. It's simply what do you call horizontal scaling. So either vertical scaling or mm, horizontal scaling depending on the load that you are like CPU load that's getting. And these CPU loads, like we cannot like monitor every time. These CPU load we cannot monitor every time, like going into the server, checking into the server, whether the load is like getting heavy or not. So what we do, like we need to have the data as well, like for it for us to have like when is our like website getting a lot of users, is it like seasonal, let's say if it is our gold, and maybe like sometimes when the gold prices get low, or like when there is a festival called Ashadam, at that time as well, the website could get more traffic. So you have to keep a record of all this data, like when your CPU load is increasing, is it seasonal or is it sudden or something. For that, like we need to have a lot of metrics data, and this metrics data, everything can be stored in Prometheus. This is where Prometheus helps in picture. And you have to bear in mind that Prometheus does not help in like logs and traces. There are other tools for it. Like we will be constraining with Prometheus here. So Prometheus helps us in getting metrics of the data. Metrics is simply put what's your like CPU load, like your memory or disk space usage and everything. And here one more thing is Prometheus is just a database. And by the database I mean it's called as time series database. So, as you know, database is nothing but to store the data. But let's say in our EC2 instance, like we want data, like whatever the metric CPU load and everything to be stored inside the database. So we cannot manually like store every data, like you could take it and like you put that like back in the database. We could not do that. So for that, like we will use exporter tools. So there are other tools called exporter tools, and it could be like Node exporter, it could be Nginx exporter as well. Node exporter or Nginx exporter, we'll talk about both in this session itself. So what these exporter does is like go grab the data from EC2 instance or Kubernetes node or anything, and just pass this data, like update this data in time series database. Like it's more like you had to, since it is a database, you had to get these things, like whatever it is, like if you want to check the CPU time, like to CPU load 2 minutes ago, you had to have a query for it. So for everything, it's just a query. And just like here is one of the query, and based on that, like Prometheus has in queries. So but for us, like the queries are not comfortable. That is where we'll use Grafana for visualization, that we'll talk. And here one more thing here, like Prometheus here, like because it calculates time, not just like from tomorrow or yesterday. It's by default it calculates from this time. It's like Jan 1st, 1970. So let's say like it calculates in seconds or milliseconds from there to here, from Jan 1st, 1970 to 13th April 2025. It means you'll have like lot of values, and you had to like use other tools to decode that number as well. So in order to avoid that decodation, and in order to like avoid these queries, like we need some simple tool, and that could help us better. That is where like Grafana helps us in picture. So what this Grafana does, Grafana is nothing but just a dashboard. So it's like whatever the data source is there, like we will be visualizing this. Okay. We will be visualizing this Prometheus, whatever the data it got into Grafana, and like we will visualize that. Uh, till here clear, right? It's a simple. First, the EC2 instance, whatever is running, we'll get the metrics. Like we'll have node exporter, like putting the data into Prometheus, and from there, like we'll use Grafana to visualize. Till here, everyone is clear, right? Yes.
Yes, Sagar, yes.
Okay.
Yeah, yes, sir.
Yeah, we'll start into the project.
Sagar, have you recorded the video? Recording is start or not?
Yeah, yeah, it started actually. I guess, yes. Yes, it started. It's in recording.
Okay. Okay, sir.
I did not test the recording today, but I think like everything works fine. If it doesn't work, maybe I have to take another session. That's it. Nothing more we could do. But I'm sure it's recording. Okay, I forgot to log in. Yes, just give me a minute. Mm, I don't know. The authentication's increased. Ah, it's like three, four authentications. Pixel, okay. Yeah, I'll close whatever is not necessary. Here is where. Where is the one that I logged in now? Hmm. Okay, I think I have to sign in again. Okay, fine. Yeah. So for this session especially, I'll be taking a new instance. Just as you know, like not to. Because send the Grafana. Because this is an individual session, I don't want to like use this in the other instances as well. So that is why I'll just take T3 medium for it. Keep here because I'll just log in through console. I could go for anything and just launch instance. Hmm. Yes, first thing is like since we want Prometheus and Grafana using Helm Charts, and Helm Charts is nothing but a packaged application of Kubernetes. That's where I said like first install Kubernetes and then Helm Charts and then follow the blog. You could just click on this because it was Docker. Yeah, like I'm going to install Kubernetes first. Come on. Yes, Kubernetes and then like just giving the permissions. These all I'll not be explaining again. Since we decided on two sessions today, first session could be a bit lengthy, but based on second session, it could be just 10 to 15 minutes. That's it. Because everything of Prometheus Grafana would be explained here in this session, so that's where it could be a bit lengthy session here for us now. Hmm. Yes, I'll just go for using alias. Like instead of your microkate as kubectl, I'm just using kubectl. Okay, and yes, it's done. We'll go for Helm charts installation. So in this system, I just installed Kubernetes and Helm charts as a prerequisites. So first thing is I'm creating a namespace monitoring. As explained namespace already. It's just like individual isolation of resources. So I'm creating namespace monitoring, and from here, as you could see, since this session, like we'll be talking about official Helm charts and like official Grafana, so that's where like we'll be using this. So if you go for like for official Helm charts, you just have to like click on Helm charts repository, and Artifacts Hub is the one like which is official Helm charts repo. Just like Docker Hub we have for Docker, for Helm charts it's Artifact Hub. So if I search for Prometheus, as you could see, the star mark, the tick mark is saying that it's official thing. That's it. So I'm using the same thing here. Like instead of copying from there, will be just using our blog itself to copy paste. And in case like you had any discrepancies or something, you could just like click on like official charts, like to check whether you had given correct command or not as well. Helm repo update. So this we are installing Prometheus via Helm charts. Hmm. Now Helm install. This is the one. Helm install. Hmm. So we had successfully installed. As you could see, like there are like two things that are pending. One is like Prometheus server, push gateway would be up in some time. Yeah, push gateway is up. Like Prometheus Alert Manager and like Prometheus server, these both are in pending state. As you know, like if these are in pending state, we need to know why these are in pending state. So you could just click on kubectl describe pod. So as you could see, pod has unbound persistent volume claim. So this means like this is a concept of PV and PVCs. Where is .dot okay. PV and PVCs is nothing but just like you have Docker volumes. It's just like one would be attached inside like the pod. Let's say the pod has PV or PVC. Mm, okay, I think it's coming on top. Okay. The pod has PVC and like you had to attach this to a PV, and like PV is nothing but like where in your EC2 server you're telling at a particular time like you want an instance. Mm, yeah, you're telling at a particular instance, like let's say like I want the data to be at a particular location, like whatever the data the pod is having, I want that to have at a particular location and inside our AWS EC2 server. So what happens with this is even the pod is deleted. So you have the PV and PVCs you could attach. Let's say it's morely like in the database you could think of. Let's say a pod is deleted by accident, but you still have PV and PVCs. What you'll do, you'll turn up a new pod and you would attach the PVC that is unbound to this pod. So in this way, it's like even you have like database, even the pod is deleted, your data is still secure at a particular location in your server itself. Got the idea between PV and PVCs? It's like persistent volume, and another one is like persistent volume claim. PV and PVC stands for. So this one like pod has like PV, but it's looking for sorry PVC, but it pod has PVC, but it's looking for PV for it to attach. It's more like both have to bond, like one in the pod and one in the AWS EC2 server. So if I go for PVCs, like what PVCs are there? So both PVCs, like both for Prometheus server and both for Alert Manager, both are in unbound state. For it to happen, like here in the blog itself, I had PV and PVCs. Like what is this? Okay, this is the one. Yeah, PV and PVCs. And for you to check, like how can you attach the particular PV to PVC? You cannot directly attach. For that, like the server or Kubernetes must take care. For it to attach PVC, like we had to take certain criterias to like place. Yeah, kubectl describe. No, let's go for edit. Edit PVC minus n monitoring. So as you could see, like certain criterias for it to attach PV would be the PV must have these things. Like access mode must be like read write ones, and storage must be 2GI, and volume mode must be file system. Only if the both are in parallel sync, only then this PV would be attached to PVC. You could not directly attach. So that's one thing to bear in mind. I think like I had a repo for it as well. Yeah, it's day 12, right? One second. Day 13. Sorry, yeah, my bad. It's day 13. So since there are like two things, one is like alert manager PV and another is like server PV that we need both the PVs. So as you could see, the alert manager PV just like there 2GI file system and read write ones, which is the one like I kept there. And in EC2, as I explained, in server as well, we need a particular path like where this data must be stored. For that, the host path is like mount data alert manager. For this I kept, and for this to have we had to create this path. Same goes for Prometheus server PV as well, as there are like two PVCs, like two pods that are in unpending state because of PV and PVC unbound. So we'll do that both here. So for that, I'm just creating both, like one for Prometheus, one for Alert Manager, because there are like two PVCs and two pods as I explained. So I'm just and the other thing, oh no, it's like just creating and like giving permissions. I'm just giving permissions for it, and then it's just the host path that we are setting, like in AWS EC2, like which path or volume must be there. And now there, as this is set, like we'll go for creating PVs for both Prometheus server and Prometheus Alert Manager. So I'm not just taking names, I'll be just taking random Prometheus server PV dot YAML. Here kubectl apply minus f pspv dot YAML. Okay, this is created. And other thing is, yeah, now if you see like kubectl get PVC minus n monitoring, because this is for Prometheus server. Okay, this why did not it bound yet still. Yeah, see, as you could see, it got bound. So instead of pending. Now, if you see even the pods now, because like we had resolved the issue of like PV and PVC for one pod, yeah, it goes for container creating. So instead of pending, so it's starting to create the pod. So it will create in some time, so nothing to worry. Meanwhile, we'll get the other thing as well up. Yeah, the alert manager PV. VI alert manager. Okay. Yeah, so both the PVCs are bound. Now let's check the pods. Yeah, so our pods are running. It means like we had fixed PV and PVC issues, and our Prometheus is now running perfectly in our EC2 server. But like since Prometheus is like a database query, and like we want to use it accessing via UI, so that is where like we'll use NodePort here. So the NodePort is something like, where is this? Like the Prometheus server is the one which is in cluster IP. If you want to access within the server itself, it's just like curl HTTP colon slash slash. The IP of Prometheus server is 10 dot, oh sorry, 10 dot 152 dot 183 dot triple two colon 80. Okay, query not found. It's just like it's waiting for query for us to update. But now, like since we are really not able to use via terminal, like we'll just expose it like via NodePort, so that like we can use our uh, s- browser itself to run whatever queries we need. It's just you had to change it from cluster IP to NodePort. Now if I give NodePort again, it's running on 313332. For since it's a new server, I'm just going for security. There is a like inbound rules. I'll just allow that port for us. What's the port again? 313332. And you can actually give the node port IP here as well, but it's Helm charts. I'll also tell like where you had to change. You could not change here directly because it's installed via Helm charts. So 313332 public IP. Okay. So as you could see, it's the one, no data queries required. This is the one like that we are trying. So if I type any one query, let's say like this, I'll be using the same query for it to show. Hmm. Execute. As you could see, like CPU or 2 seconds ago, it's actually joining in like milliseconds or like the load. But if you want to calculate the time at that particular time, it's like more like you have to calculate via milliseconds and from the epoch time, which we'll be looking into Grafana as well. And one more thing, like whatever, like as you could see, it got from via labels, like what Prometheus is calculating. One is namespace monitoring its own node, and even the other name. Okay, I don't think it's calculating other namespaces. Fine. Like whatever the Prometheus is like calculating, you could check it in target health. So what data it's pulling from? One is this, like Kubernetes API servers, and other one is endpoint, other one is node CI advisor, and like everything is in like slash metrics, which is of Prometheus instance slash metrics. These are Prometheus instances. Since you have to understand it's a new server and we do not have any application running. Now, like we'll see with an application running. Till here, the part is clear, right? Regarding the Prometheus installation and other stuff, like PV, PVCs and Prometheus installations and NodePort part. Yes. If you guys could unmute and speak. Hmm. Fine. So since this is installed via Helm charts, what I'm doing because it's official Helm charts, we do not have values.yaml file. We pulled it from here. So what I'm doing is like getting the official Helm chart values and I'm updating in values.yaml file. So once it is updated, what I'm going to do is okay, like before this, I'm going to actually turn up an application in R because this actually doesn't have any application for us. So I'll be taking this application and I'll be turning up there. And for this, like I had to create React microcaters namespace, which is not there. Okay. kubectl create ns React microcaters. vi vi deployment.yaml. Okay, so React Chat 1 application was created. So this is kubectl get pods minus n. Okay, React microgators, sorry, my bad. So our application is running, but we want our Prometheus to get the metrics from this application. So what we'll do, like we will use something called as scrape configs, just like the node exporter, which gets from, as you could see, there is a node exporter, like which takes our application and puts there. Like we need Prometheus to tell, like take this application as well. So for that, what we'll do, like we will be updating scrape config file. Hmm, yeah, scrape config job. So this is the one we are telling, like whatever is there, the discover pods, you had to get the scrape config files as well. As I showed, like for the values.yaml, we'll go for again vi values.yaml, and for it to like search escape colon dot slash scrape underscore configs, for it to like directly search in this big path because the file is very large. I will just using find there. Okay, we got this. One thing to take care is you had to be careful about the indentations part. It should be exactly under the scrape configs, must be under the job names itself. So I'm just using this. It got disturbed a bit. We'll adjust this. Okay. Just checking. Okay, so everything is fine. But this is a new values.yaml because the one not from official. So we had to tell Prometheus to update from the new values.yaml for it to update. Like as you could see, like we're passing minus of values.yaml. So once we had done this, yeah, as you could see, the pods were not restarted. Unless the pods are not restarted, the changes would not take place. So I'm just manually restarting the pod because these are in deployment. You could just delete the pod, it will be up again. Okay. And one more thing is like since we had like Helm upgrade, even our service would be like restarted. As you could see, it went back to cluster IP. We had to change this again to NodePort. And there is another way as well to change this. Like instead of like changing this to every time and get the NodePort, I'll show like within like service file itself. So this is now under 30462. So here just because it's a demo, I'll be allowing every port 30462. Okay. Now it will be like 30462. Yes. Here if I go for target health, yeah, as you could see, this is the IP that's for our pod Nginx pod that we had the scrape config. It says the state is down. This doesn't mean the state of pod is down. This actually a bit of confused that I'll show here. kubectl get pods minus n monitoring minus n, sorry, react micro k8s, react micro k8s, and for us to get the IP, it's like minus 0 wide. So this got the IP. So as you could see, 10.1.106.35. This is the same as this IP. What is it searching? Like it's searching colon 80 slash matrix. So if you go for as simple as that, if you go for application HTTP colon slash slash 10.1.106.135 slash, okay, sorry, colon 80. So the application is there, but what is Prometheus checking? It checks for slash matrix. It's actually thinking like by default, Prometheus checks colon 80 slash matrix is the matrix path of any pod. But here we do not have metric path here. And to get actually the metric path, which would actually be told by developer, like on which port it's running and like which API the metrics are there. Because we do not have our application designed by developer and by own, like we are actually, I'm here actually using Nginx exporter for our application to have metrics API. So I'll be showing that here itself in Nginx. So instead of like having in the deployment file, what I'll be doing is yeah, I'll be updating our what do you call deployment file with additional of this line. Like more, you could call it as a sidecar container. It's just a support for our container. It's just like another application. It's just like API. Like, as you could see, here is in our application, we have like slash targets. If you go for query, it changes for slash query. Similar way in our application, like we're adding one more port and it'll be like our pod IP colon slash port slash metrics. It's actually a helping container for us, for our application to get the metrics. So for it, the same lines which I showed in the blog. I actually, yeah, I had this deployment file, so I'll be just using this deployment file. It's the same. It's just like the last these lines were added. These lines were added, and like Prometheus annotations were added. That's it, and nothing more. So vi uh, new deploy dot YAML. Okay, now if I go for get pods minus n micro k8s. Okay, sorry, React micro k8s. As you could see, this is running. If I go for minus 0 wide, this has IP, but if I want to check the metrics, as you could see in the deployment file, metrics port I had given like colon 9113. So our metrics port would be in metrics API would be in 9113 HTTP colon slash slash 10 dot 1 dot 106 dot 137 colon 9113. So this actually shows the metrics path and it will be like slash metrics to get every metrics path. So as you could see, we got all the metrics path like inside our application. Now Prometheus by default checks in our port 80 as you had seen. So it checks the port for us in colon 80 for metrics path. But now we had like different port and different API. We need to update Prometheus saying that like we had it in different path. So for that, yeah, we'll be adding just like these two extra lines in our code, like which we had like earlier setup. So it's like vi values.yaml. So the same process would be repeated again. And one more thing, as I said, if you want to like change application itself from NodePort to this, okay, there are a lot of service. I think like it's hard to find service. But I guess you understood like what I'm talking about while I explained in Helm Chart session. So I think like we'll look at that later. Script underscore configs. Hmm. Yeah, we had to like now add those two lines which we copied here, saying that now our path has been changed. So how would the path be changed? It's this path. It's like the address 913, pod IP 91313 is where you find the metrics, not on colon 80. Is where like we're updating Prometheus there. Okay. It actually got a bit of syntax issue. Okay. Here is the one like we are replacing the path. Like instead of colon 80, it should be uh, in the 9113 path. Okay. Now the same process goes since we updated values.yaml file. We had to update it with this is with the new. Okay. Okay. This is done. Yeah, this is done. This is done. Yes. Helm upgrade with new values.yaml. Uh, yes. It's the same process again. Kubectl get pods minus n react microKTs. Okay, not minus n. We'll restart this. Okay. Now one more thing is like we had to service as well gets changed as we had seen previously. So it's now 30701. Okay. Okay. So as you could see now it's like the application, the pod IP, the React demo, the Kubernetes React microKTs, and like now it checks for port 9113 slash metrics is the one. Okay. So we are successfully installed like Prometheus and everything is done. So now like we want to check oh sorry, not this, Grafana. So Prometheus is perfectly fine. Now we want the dashboard. As I said, like you could actually go for official Helm charts if you had any issues to check if this code doesn't work. Same thing, I'm adding Grafana now for us to have better visualization, like and instead of writing queries. So just like Helm Grafana update, and yes, where is this? Yeah, R Grafana is creating because I did not use any monitoring thing. Let it create, let it give some time. Yes, like we're just checking service. Service is where like we'll get the replication up, just like we did it in Prometheus as well. So as you could see, Grafana dashboard is the one like which we would be changing it to. Same thing, NodePort. Yes, let's see where is our Grafana. Our Grafana is in 32023. So we'll just go for 32023. Yeah, we got our Grafana ready, and like by default the username is admin, and to get the password, just like Jenkins, like while we're configuring, we had secrets. I mean, like inside one, the same thing Grafana as well does. It has like secrets, and inside secrets, you get this password to decode. So Grafana dashboard is the one that's the secret is there, and since it's JSON path, and if you edit the JSON secret, you will get like data admin password. Just it's just like JSON query I'm getting, and I'm using base64 decode here. Okay, I think yes, we are at the edge of the session. Okay, fine. Hmm. So base64 decode. You had to observe here the Ubuntu is just like Ubuntu at the rate IP, and before that Ubuntu, just copy everything from Z. That's the our password. Mm, yeah. So this is our password. Okay, we logged in successfully. Now, one thing to do is like to establish connection because this is Grafana dashboard and we have like database inside Prometheus. That's where like we'll go for Grafana, like connections and just for search for Prometheus. And here in Prometheus, we'll just add new data source and Prometheus IP is just this, the one that we configured in the server. And now just click on save and test. So you had successfully saved Prometheus. Now we want the dashboard. So for dashboards to appear, like we do not like we could use existing dashboards that are there. So we'll go for import, and by default, for Prometheus, it is 3662 that will have the dashboard. Yes. Okay. The data source that we had configured is Prometheus, and we'll just import the dashboard. As you could see, this is our dashboard, and yeah, as you could see, these are our my React Engine export, the script configs that we did, and Prometheus that we did, Prometheus push gateway. These are all by default scraped by Prometheus. So clear on this Prometheus and Grafana session, right? Like how we'll actually uh, take everything. Now, like we will get into Prometheus and Grafana using a cube stack Prometheus where things are much simpler than this. Like because here we configured PV and PVCs, and then we had to get the application in script configs, and then we had to connect Grafana to Prometheus. Like this is actually a bit of not a complex things, but an initial setup is different. And every time you get the application, you have to update the paths and everything. That's where we have another Helm chart called Kubestack Prometheus, especially helpful for Kubernetes stuff. So yeah, I'll take that session as well. I'll be ending this meeting because it's just like 10 minutes. So everyone is clear on this session, right? I'll be sending new link in the WhatsApp channel now. So clear or any queries regarding this? Yeah, Vishnu, Pawan.
Yeah, clear. Clear, Sagar. No, no.
Okay, I'll actually send a new link in our WhatsApp channel. You could join there or you could leave here. Yeah, thank you. I'll be calling there. Yes, bye.